Hi everyone, Miss Maringer here. So I'm going to just go over the do now real quick with you guys and then go through some of these key terms, vocabulary before the investigation. So if we look at do now, we're just simplifying the following expressions. So you guys have seen this before. This is just a little review. So if you remember, when we are multiplying the same variable, you just add the exponents. So that's how, so for number 1, we get 3 plus 5 equals 8, which is how we get x to the 8. And then when you're dividing the same variable, you subtract the exponents. So 8 minus 2 equals 6, which is how we get y to the 6th. And then when you are raising an exponent to some power, you multiply the exponents. So 5 times 4 equals 20, which is how we get x to the 20th. So that was just some review. So hopefully you guys remembered that. So now if we look underneath, we're just going to go over some key terms and some rules. So the common logarithm has a base of 10. So log base 10 x and log x mean the same thing. So if we don't specify what base it is, we're going to assume that it's base 10. So that's why here we can just say that log x is the same as this, log base 10x. Same thing, okay? Next bullet point, the natural logarithm has a base of e. So log base ex and natural log, this ln is the same as natural log x. So these two expressions mean the same thing, okay? So again, if we don't specify the base and it just says ln of x, it means the same thing as this right here, okay? So now some properties of logarithms. So if we look at this first one, log base a1 equals 0. So we would rewrite it as a to the 0 equals 1. So anything raised to the 0 equals 1. So that's why if we have a log base a, or it could have been log base b, but it's still 1, so it's going to equal 0. Anything raised to the 0 equals 1. So if we look at this next one, log base a to a equals 1. So when we rewrite it, it's a to the 1 equals a. Okay? Then if we look at this next one, so we have a little note up here. We want to rewrite it as a log. So this is written as an exponent. We want to rewrite it as a log. So how we would rewrite it would be log base a to the m equals log base a to the m. And since these have the same base, we can just write m equals m. So it's a similar rule as if we have the same base as exponents, we rewrite, or we write the exponents are equal to each other. This same base, log a, log base a, equal to each other, so we just write m equals m. And then this last one, we have log base a to the r equals r. So if we rewrite this, we would rewrite it as a to the r equals a to the r. So again, same base. So the exponents are equal, which is how we get r equals r. Okay? So now let's jump down to this example. It says 2 to the log base 2, 7 equals 7. Okay? So how we get that is if we were to rewrite this example as we did this problem, we're going to use this property, so then we can just say that it equals 7, because if we wrote log base 2, 7 equals log base 2, 7, we get this log base 2, 7 from the exponent. And then again, log base 2 is equal to log base 2. So then we get 7 equals 7, which is just 7. Okay? So take this next 5-10 minutes or so, do the investigation, and then watch the next video.